The question number 41 is a whistle emitting a sound of frequency 450 Hz approaches a stationary observer at a speed of 33 meter per second. The velocity of sound is 330 meter per second. The frequency heard by an observer, that is student, Doppler effect is taking that this is the source and this source is moving with the speed of 33 meter per second and so emitting the sound with the sound velocity equal to 330 meter per second and the frequency emitted is 450 Hz. And there is an observer at this point. And what is the frequency heard by the observer? And see, the sound will cross this way, and the formula for the observed frequency is the real frequency, the velocity of sound relative to observer divided by velocity of sound relative to source. That is 450 into velocity of the sound, that is 330. The observer was at rest, divided by velocity of sound relative to this, that is 330 minus 33. Now solve this equation, that is this is equal to 500 Hz. So the correct option to this is option number 4. Let's move to the next problem. The question of 42 is when an open organ pipe resonates in its fundamental mode, then at the center of the pipe. Now see, the tube is in open mode. So what happens in the middle, like this one, a sound goes and then returns from somewhere away. So this become a location of node. And see, at the node there is maximum pressure variation. And look at the option. The gas molecules undergo variation of the maximum amplitude. The gas molecules are in motion. The pressure of the gas is constant. The pressure of gas undergoes maximum variation. Yes, at the location of the node, the pressure variation is maximum. So answer to this question is the option number 4. The question 43 is a string of length 0.4 meter and mass 10 to the minus 2 kg is clamped at its ends. The tension in the string is 1.6 Newton. When a pulse travels along the string, the shape of the string is found to the same at the time t and t plus delta t, the value of delta t. Now dear student, this is the string whose length is given to be 0.4 meter. Length is this and its mass is given to you 10 to the power minus 2 kg. Now one pulse is created here at time t. Now the same shape will be generated when this will return from here and reach back here, and that is given the instant t plus delta t. So delta t is basically the time when this wave travel a distance of 2L with certain speed v. So we have to find this pulse speed and the length, that is distance travel is this, and v we will calculate. How will you calculate v? V is equal to tension divided by mass per unit length. The tension is given 1.6, the mass is 10 to the power minus 2 and length is 0.4. So when you fill this, this comes to be 8 meter per second. And fill here, so it is 0.8 divided by the wave speed, this is right. So it comes to be 0.1 second. So the correct option is the option number 2. The question number 44 is when a stretched string of length L is vibrating in a particular mode, the distance between two nodes on the string is L. The sound produced by this mode of vibration constitutes nth overtone of the fundamental frequency of the string. Then the relation between capital L and small l. Now it says that the distance between the two nodes, which is lambda by 2, is equal to L, therefore the lambda is equal to 2L. The sound produced by this mode of vibration constitute nth overtone of the fundamental. Nth overtone fundamental means n plus 1 of the first harmonic, which is equal to n plus 1 the sound velocity divided by 2L. And this, the frequency would be equal to v by lambda, and lambda is equal to 2L. So we'll solve from here, the 2 cancel with 2 and v cancel with v. then the relation n plus 1 into small l is equal to capital L. And the correct option is the option number 1. The question number 45 is the equation y is given equal to a cos square 2 pi nt minus 2 pi x by lambda represent a wave whose amplitude and frequency are to compare. Now the relation y is given equal to a cos square and bracket is 2 pi n into t minus 2 pi x divided by lambda. Now dear student, cos square theta is equal to 1 plus cos of double of angle divided by 2. We have to use it. So y is equal to a, and instead of this is 1 plus and cos and double to this one, that is equal to 2 pi 2nt minus 2 pi 2x divided by lambda and whole multiply by 2. So y is equal to a by 2, 1 plus, now this equation, cos of 2 pi 2n into t minus 2 pi x, and take to this in denominator lambda by 2. So this become equal to y is equal to a 1 plus cos of omega t minus kx, and 2n becomes the frequency and this lambda by 2 becomes the wavelength on comparing. So see, what is that? The amplitude is a by 2, frequency is 2n, and wavelength is lambda by 2. So amplitude is a by 2, frequency is 2n, and wavelength is lambda by 2. Therefore, the correct option is 4 to this one. Thank you dear students. Thank you for watching and keep working. Best of luck. Thanks a lot.